All right, folks. So, gonna do some recap from yesterday. Yesterday, the main thing we wanted to make sure you were able to do was use PEMDAS. So, if we remind ourselves, PEMDAS multiplication and division happen simultaneously, always from left to right, and so do addition and subtraction, always from left to right. So we can't be lazy. We want to make sure we're following those steps carefully. So the first thing we're going to do is take care of parentheses. So in this case, we're going to add these two together. So if we add 4 plus 2, that gives us 6. Well, that's now multiplication because you had the negative 2 up front. So we now have negative 2 times 6. And then we don't want to be lazy again. We're going to rewrite our plus 8. Okay? So now from here, we're going to multiply from left to right. We're going left to right. So we're going to multiply first. That gives us negative 12. Plus 8 is still there. We can combine those. We're left with negative 4 using addition. So using PEMDAS, we simplify there. We're left with negative 4. So take a second, write this one here, this number 2, out on a piece of paper for yourself. Try it out and press pause on the video so that you can give this a shot on your own. And then you can come back and watch me do it. All right, so first things first, parentheses. So 3 minus 2 right here, so that gives us 1. So I'm going to rewrite the rest of this as we go. So we have 2 minus 4 plus 6 times that 1. That's multiplication. And then plus, let's go ahead and take care of exponents. So 2 to the third power really means 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power is 8. We're adding 8 there. All right, next is multiplication and division. We have multiplication right here. So we're going to multiply those together. That gives me simply 6. So now we have left behind 2 minus 4 plus 6 plus 8. And to finish it out, now we simply add and subtract from left to right, which means we have to start over here and then slowly make our way to the right-hand side. So to do that, we're going to start by subtracting 2 minus 4. 2 minus 4 gives us negative 2. Then just rewrite everything else that was still there. So the plus 6 plus 8. So now from there, we're going to combine negative 2 and positive 6. So negative 2 plus 6 leaves us with 4. So 4 plus 8, that's our final piece. 4 plus 8 gives us 12. So being very careful to use PEMDAS there is a really important skill to starting out here in Foundations of Math 1. All right, so if you grab your notes, what we're going to look at today is what we call functions and evaluating a function. So we have something here called function notation. And function notation is where we have an equation essentially or a function right here off to the right-hand side. You want to pay attention to this piece. And the way we read that is we read that by saying f of x. It's basically a function of x. So x is what you are essentially going to be plugging in. You're going to be plugging x in, and that obviously you can see there's an x right here. So the one thing that I want you to remember that a lot of students make mistakes on is this f of x component here on the left-hand side. That component is not, you don't do any math with this. There's nothing to add or subtract. There's no multiplication or division. There's really no math to do here. This is simply kind of our notation or the way we write it. So let's jump in right away. Let's see what we've got here. We've got a bunch of different functions, f, g, h, s of t, lots of different functions. And really what we're saying is we're plugging variables or values in to each of our functions. So to do that, f of x is the function notation, another way of representing the y in a function. Okay, so fill that in on your notes. Really, the f of x is the same as saying y equals. So f of x equals is the same thing as saying y equals. So we have lots of different functions here that we're going to essentially be plugging in. So back up here to these lines right here. What's happening is this part here is the output. Okay, this is what we're going to get out of the function. And this part is where we create the function. So this is what we call our input. So we have an output and we have an input here. So really important that we have a good understanding of what those two pieces are. All right, moving on. So here, let's actually take an opportunity to kind of practice this. So if you notice, it says, let's find f of 2. So there's not an x there. We've given you a number. We've given you that number 2. And then it does give us the function 3x. So very, very basic equation, but we're going to see what this looks like. So what we're trying to do is we're asking, let's find what f of 2 is. What that really means is when x, what's our variable there? X is 2. This number comes from right here. It's really important that we have a good understanding of that piece right there, that the 2 is the number that was in the parentheses. That's what x equals. So we're going to find this equation, and the equation that was given to us was f of x equals 3x. So essentially what we need to do here to evaluate that is we have f of a number, and that number was this guy right here. So we plug that in. So f of 2, remember there's no math here. This is not math. What we're doing now is we're simply plugging into our equation. So our equation was 3 times something. And that something is the number 2 that we were given. So 3 times 2, that simply equals 6. So there you are. F of 2 is equal to 6. So that's function notation and how you evaluate a function. That's a really important skill to what we're trying to learn in Foundations of Math 1. Okay? All right, so let's keep it rolling. We're going to keep practicing that same idea and look at how you would use this and kind of in some more examples. So notice here we've given you a function 3x minus 5, and we're asking you to find f of 4. So just like we did before, we're now going to take the number you were given, the 4, and we're going to plug that number into anywhere you see an x. In this case, we only see one x, but we're going to plug it in. So here's the deal. So to use our Sorry, the interruption. All right, so to use our notes here, what we're going to do is we're going to we're going to plug in the number 4 into the function in place of x. So f of 4, all right, f of 4, we're plugging that number in. So instead of 3x, it's now 3 times 4. So 3 times 4, if we simplify, is 12. 12 minus 5 is 7. There you are. So try this one out right here, number 2. See if you can figure out what h of b is, and then figure out when b equals negative 3. Give that a go. Press pause and see what you get. All right, so if we plug that in, this would be 3. I'm going to do parentheses something squared minus 2 times something plus 1. So notice how I've kind of written out the entire function right here, just no b values though. I've left a blank or parentheses everywhere where there was a b value. So now I'm going to take that b value and I'm going to plug it in. Negative 3 right there, negative 3 right here. So now that I've plugged those in, now I can start simplifying using PEMDAS like we just practiced. There's really nothing to do inside these parentheses here. So we're simply going to jump straight into the exponents. So exponents would be this guy right there. Negative 3 to the second power. Be careful. Negative 3 squared is negative 3 squared is negative 3 times negative 3, which gives us positive 9. So we now have a positive 3 still hanging out in front and a positive 9 as well. So 3 times 9. All right, 3 times 9. And then we keep going. Here we can start actually multiplying. So this is negative 2 times negative 3. Negative 2 times negative 3 is positive 6. And plus 1 still there. We can do one more multiplication. This gives us 27. 27 plus 6 plus 1. That's going to end up giving us 27 plus 6 gives me 33. 33 plus 1 gives me 34. Okay, so some good notes there, some good practice. Press pause, rewind, rewatch it as much as you need to, and we'll keep working.